working as an assistant professor in the Department of Computing Technologies in SRM AST campus, KTR campus. Today, we are going to discuss about scheduling methods. What are the scheduling algorithms are there? What are the uses of scheduling? What are the types of algorithms are there? Today, we are going to discuss about the algorithms and methods, what is meant by CPU scheduling, everything. So, what are the topics? CPU scheduling, real-time scheduling, and deadlock scheduling. Before that, we should know about what is meant by scheduling. Scheduling means just we are arranging the data. Which one comes first? Which one comes next? So before we are going to start the process, we need to arrange the data. So based on the arrangement only, we can send the data one by one into the processor for the execution. So this is called as scheduling. The scheduling, the types of schedulings are first come first serve, SJF, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. So whoever comes first, the people are standing in the queue for collecting the tickets. So whoever comes first, you can collect the ticket. So first come. So these are the scheduling methods. So who are all standing in the queue? Who is standing in the front? So he can collect the ticket in the first. And who is next? Like that, we are arranging. Shortest SJF is shortest job for schedule. So we are arranging the jobs in the order for execution into the CPU. So before that, we need to check which task it will take very lesser amount of time for execution. We need to identify that. So based on that, we are sending the task one by one into the CPU. Example, we have taken 10 jobs are there standing in the queue for the execution. That time, we need to assign the priority for each and every jobs, like that is the criteria. Based on some criteria only, we need to assign the jobs into the CPU, right? So here the time duration is the criteria we are fixing for that. So based on the shortest time duration, the shortest time duration which comes first, so the longest period, the jobs it will take the longest duration of the execution, so it will come next. Based on that, we are arranging the jobs. This is the second method. The next method is priority. So priority, the name itself meaning is there. So which one executed first in the process? Who is first? Before we start executing the task, we need to assign the priority. This one comes first. This one comes next, like that. And round robin. Round robin in the sense, here we are fixing the quantum for each and every task, like so in which job, each job it will execute within the processor within the minimum duration of time. We are fixing the time duration for all the jobs in the fixed 3 times it will be executed within the processor only for 3 seconds. Next job, so the next job it will execute in the processor next remaining 3 seconds, like that we are fixing the time duration. Multi-level queue means multi-level queue means, so here the processor is assigned for execution. Here multi-level queues are there. For each queue it contains different tasks for execution. We can send the job one by one into the processor for execution. Multi-level feedback queue scheduling. What does the meaning of multi-level feedback queue means? So multiple queues are there. Here we are sending the task into the one queue, one processor. It will not execute the task within the particular duration. Next, we are sending the job to the next queue. It needs to wait for some time. Next, in that queue also, its time is not enough for the next. You need to send the process to the next queue, like that. So these are the real-time scheduling, rate monotonic scheduling, and deadline scheduling. Deadlocks. Deadlocks means, so the two tasks trying to access the same processor at the same time. So the two processors are trying to access the same resource. So if you are using the same resource, two process, but it will take time. So first one process is take the resource and execute the task in the CPU. Not like that. Two process trying to access the same resources at the same time. So this is called as that time what will happen. So no one can complete the task within the given duration because the two processes trying to access the resources that time what will happen. So some lagging, the time lagging, some delay, resource delay, everything is there. So we are going to discuss about these topics. Next one is process scheduling. The process scheduling in the sense, so how we are executing that. What is meant by process? Something is in execution, we can call it as, that is program is in execution, we can call it as process. Before that, if once we check the diagram, load, store, add, store and read the file. So some input outputs are not available in this, means you need to wait for the input for some time. So after getting the input only we need to send this for the execution. So load CPU burst time means, what does mean by CPU execution time? Once we are sending the addition operation into the processor means how long time it will take for the execution. So that is called as CPU burst time. The input output out time, how long time it will take to collect the input output data from the user, whoever start ready to execute the task. So for that, that is called as CPU execution time and the IO burst time. So what next? We should know the terms very clearly. Preemptive or non-preemptive. What is in by preemptive and what is in by non-preemptive? Preemption means, so one processor is there, so two jobs are waiting in the queue. One process is entered into the process for execution. If the higher priority process comes, what will happen? The processor automatically switch over to that process for the to execute that process. That is called as preemption. How the example I am telling, that is for execution of each process 5 seconds. Oh, 3 seconds over within the processor. What will happen? At the 3 seconds, another process is ready to enter. So if the priority of that new process is higher than the inside process, so automatically preempt to the third process. So that is called as preemption. Non-preempt never preempt the task. Once it complete the old process, after the completion of the old process, it's automatically move to the new process. So here totally 5 states are there. What are the 5 states means? New state, ready state, running state, waiting state and termination state. So the new process is submitted into the ready queue for the execution. So actually ready is a one type of queue. From this queue only we are sending the task one by one into the running state for execution state. If once we are sending the process from ready to running, if the input outputs are not there, so it needs to wait for some time, means here the waiting queue is there. We are sending the task again into the waiting queue for collecting the data and informations. After that, we can, after collecting the data from the waiting queue, it automatically move to the termination state. Dispatcher. Dispatch means how we are dispatching the data from running to termination, termination to, that is ready to running. How to dispatch? Move the task from run ready to running. Dispatch. Move the data from one location. That is the basic meaning of dispatch is how we are dispatching the data from one location to another location. So this is called as dispatch. So these are the scheduling criteria are there. CPU utilization, throughput, response time, waiting time and turnaround time. CPU utilization, how long time the CPU is utilized for the particular process. Throughput means number of process completed per unit of time. Response time, how long time it needs to wait. Waiting time. Okay, the waiting time is the amount of time the process has been waiting to ready queue. In the ready queue, turnaround time, amount of time to execute the particular process from the time of submission through the time of completion. So this is called as these are the scheduling criteria, the scheduling algorithms. First come first serve, preemptive, non-preemptive, round robin, multi-level queue scheduling, multi-level feedback queue scheduling. So the next the thing is your first come first serve. So these are the problems. So burst time is given to you. That is the execution time given to you. The based on the execution time. So P1 is 24, P2 is 3, P3 is 3. So first before that we need to draw the Gantt chart for that. So P1 24, P2 20, that is 3. You can add it. So 3 can second after the completion of the P1 only the P2 process can enter into the processor for the execution. So it will take 3 seconds. So you need to add the 3 seconds with the P1. So the P2, how long time it should wait? It need to wait for 24 seconds. After the completion of the 24 seconds only, P2 process can enter into the processor for the execution. For next P3, so how will you calculate the average waiting time and turnaround time is the addition of the waiting time, addition of turnaround time. Waiting time of P1 is 0. No needs to wait for any procedure. It directly you can enter into the process for execution. Whatever the P2, if you want to enter the P2 means it needs to wait for 24 seconds. P3, 27 seconds needs to wait for some time like that. Turnaround time is nothing but completion time, we can call it as turnaround time. So how long time the completion is? 24 seconds completion, 27 seconds, 30 seconds it needs to wait for some time. So the another problem is given to you. You by using the same method you can solve this. Okay, and next one is SJF. So here you should which one executed first at the based on the shortest duration of the time you can enter the task one. So now we discussed about scheduling, what are the types, everything we discussed. Two problems also we discussed how to solve that first come first serve, and SJF also we discussed it right now. So in the next video we'll discuss about the remaining scheduling algorithms.